The question is, A is a binary compound of the univalent metal. So univalent metal basically are the ones which have +1 in their cationic form, and binary compound means the molecule which has two different atoms. Okay. When 1.422 gram of A reacts with completely with 0.321 gram of sulfur in an evacuated and sealed tube, 1.743 gram of white crystalline solid B is produced, which produces a hydrated double salt C with Al2SO4 whole thrice. Identify A, B, and C. So, how to approach such kind of questions? Since A is the binary salt of a univalent metal A, and when it is treated with sulfur in the evacuated tube, it forms a crystalline solid B, which is a sulfate basically. So A must contains our metal plus oxygen. Okay, so here our metal, since univalent, is M plus, and our oxygen is present as superoxide, so it will be O2 minus ion. Okay, so MO2 when treated with sulfur, it forms MSO4, M2SO4. Such kind of reaction will take place. Okay, that's why our oxide will be superoxide basically. Okay, this is a superoxide. Now we can see from this reaction that 2 moles of oxide reacts with 1 mole of sulfur to form 1 mole of solid, which is sulfate basically. Moles of sulfate will be equal to half into moles of oxide, which implies moles of sulfate is, the mass of sulfate given is 1.743 divided by molecular mass of sulfate. Let molar mass of element M be X, then it will become 2x plus 32 for sulfur and 4 into 16.16 for oxygen. Sorry, it will equal to half into moles for oxide. So mass of oxide is 1.422 divided by MO2 X plus 16 into 2. Now if we solve, then it will be equal to 1.743 divided by 2x plus 96 equal to 0.711 divided by x plus 32. Okay, so on solving we get 1.743 x plus 32 into 1.743 equal to basically 1.422 x plus 0.711 into 96. So on solving we get 0.321 x equal to 12.48. So on solving we get x equal to 38.8, which is approximately equal to 39. So our molar mass of the monovalent compound element is 39, which corresponds to calcium, potassium. Sorry. So our element is potassium. Okay. So our A will be KO2. Okay, now if we talk about B, B is potassium sulfate, and C is the alum basically, which is the double salt. C is the alum, K2SO4 dot Al2SO4 whole thrice dot 24H2, which is basically our potash alum. So I hope that I made myself clear. Thanks for watching. Have a nice day.
Hello students, welcome to Doubtnet. So now, first of all, let us see the question that has been given to us. So in the question, we have been given two solutions. The first one is of lead nitrate, right? And the volume to which and the molarity to which is given. And we have another solution of chromic sulfate, right? And the similar data, we have volume and the molarity to which is given. And just by mixing both of them, we get a precipitate of lead sulfate, and we need to find out that how many moles of lead sulfate is formed, right? And also we need to calculate the molar concentration of the species, all the chemicals and everything that is left behind in the solution, and we have to assume that lead sulfate is completely insoluble. Now let us see how we can do this. So first of all, before we go any further, let us just write down the reaction, right? So reaction can be written something like this. So we have lead nitrate, right? When made to react with chromium sulfate, we get lead sulfate as a precipitate and chromium nitrate. Okay, so this is the ion exchange reaction that is happening here. Let us balance this. So to balance this, we need to put thrice the mole of lead nitrate and twice the mole of chromium nitrate that we have here, right? Now I can easily just look at the reaction only, and I can say that we have 3 moles of PbNO3 whole twice reacting with chromium sulfate, 1 mole of chromium sulfate, right? Similarly, just by after reacting this, we are getting 1 mole of lead sulfate and 2 moles of chromium nitrate is obtained. Now if we move further, let us just find out the number of moles of these two reactants. So number of moles of PbNO3 whole twice, just correct it, yeah, PbNO3 whole twice can be written as volume, the given volume, and the given molarity, right, into the given molarity. So the volume that we have here is let me just see. So it's 45 ml and 0.25 the molarity is. So it is 45 ml and the molarity that we have is 0.25, right? So just by doing the maths, we will be getting 11.25 millimoles, right? Now number of moles of Cr2SO4 can be whole thrice can be determined by using the same formula. So that will be equal to the given volume, that is 25 ml, and the molarity, that is 0.10 molar. So this will be equal to 2.5 millimoles, right? So as we can see that, right, I can write that here CrSO4, right, whole thrice is the limiting reagent, right? So this is true. Now if this is the limiting reagent that we have, can I just find out the amount of lead nitrate, right, that is being used. So amount of lead nitrate will be used, will be equal to thrice the moles of chromium sulfate that we have, so that is 2.5 millimoles, right? So this will be equal to 7.5 millimoles, correct? Now I can say also in this particular question that number of moles of lead nitrate, okay, is equal, the amount of lead nitrate that has been used will be equal to the number of moles of PbSO4, right? So the amount of, I can say, number of moles of PbSO4, so the amount of PbSO4 that we will be getting will be equal to 7.5 into 10 raised to the power minus 3, right, moles. So there is a slight correction if I have to do. So the reaction that is needed to be balanced here, so I just forgot to add 3 here, so it will be equal to 3 moles, right? Now it's correct. Now let me just move further. So this is something that was required for the question to be answered, right? So in the question it was asked that what amount of PbSO4 as a precipitate will be obtained, right? Now let us go further. So I can write again mass of PbSO4 that is left behind, or I'm sorry, not PbSO4 but PbNO3 in the reactant, right, whole twice, that is left. So how can we do that? So 11.25 we have millimoles minus of 7.5 that has been used, right, millimoles. Just a second, I'll just correct it. Yeah, so this is millimoles. So this will be equal to 3.75 millimoles. Okay, now what we can do is we can just calculate the total volume, right? So total volume can be calculated as total volume that we have is equal to 45 plus 25 milliliters, right? Now can we calculate the molarity? Yes, we can. So molarity of PbNO3 whole twice can be calculated as the number of moles that it has, so 3.75 into 10 raised to the power 3 moles upon we have 70 into 10 raised to the power minus 3, right? So this will be equal to 0.0536 moles, right? Now we can go a little further. So let us calculate number of moles of chromium nitrate, right, that has been formed. So that will be equal to 2 times of 2.5 millimoles, right, and this will be equal to 5 millimoles, right, 5 millimoles. Now for the same we can calculate the molarity. That will be equal to the 5 times of 10 raised to the power 3 and 70 into 10 raised to the power 3, right, and this will be equal to 0.0714 molar, right? So why we are doing this? We are just trying to find out the the concentration of all the species that are left behind. Okay, so now I can say that the PbNO3 and we have chromium nitrate, so CrNO3 whole, so this is whole twice and this is whole thrice, will be present in ionic form, ionic form. So I can write down the concentration of all the three ions, right? We have lead ion, we have chromium ion, and we have nitrate ion, right? So lead ion, Pb ion, will be present, right, 0.0536 molar, right? The concentration will be this much. And for the chromium ion, we can say that the concentration that is present in the solution will be 0.714 molar. And for the nitrate ion, I can say that the concentration that we have is 2 times of 0.0536, right? That is the nitrate ion which is present with PbNO3. So in PbNO3 whole twice we have 2 times of this ion, and then we have 3 into 0.0714, right? So this will add up to 0.3214 molar, right? So this is the amount of concentration. I mean, this is the concentration of all these species that are left behind in the solution, right? So this is the required solution for our question. I hope you all understand.